Hello everyone, this video is about a valid for or the restriction of the binomial expansion. So in the formula we have this condition x, modulus of x must be smaller than 1, or we can say that x must be between -1 and 1. So if the x is, for example, 10, the expansion does not work. So using our previous example, we have 1 plus x to the power of -1, we get this. Now if we plug in x equals 9, which is not in the domain, not in the valid for range, 1 plus 9 is 10 to the power of -1 is 0.1. As you can see, it doesn't make sense if we apply the binomial expansion for x equals 9, because on the right it's far from 0.1 no matter how many terms we use. But if we use the x value in the restrictions, so for example 0.5, which is between -1 and 1, we get 1 plus 0.5 to the power of -1, which is 2/3 or 0.666 and so on. So if we use the 4 terms, it is close to the actual exact value. Now of course if we add more terms, it'll get closer and closer to the 0.666. So here we can only use the values of x between -1 and 1. Now for this example, the x is not just x, the x in the formula is actually -2x in this question. So -2x must be between -1 and 1, and if we just we divide throughout by -1/2, we have 1/2 x minus 1/2, but since we divide by negative, we have to change the sign. So in conclusion, this expansion, if we want to use this expansion, it is only valid for the x is between -1/2 and 1/2. Another example, this time we have x squared plus 3. So this must be between -1 and 1. We multiply by 3, between -3 x squared 3. Now this is something squared. Of course it is bigger than -3, so this bigger than -3 inequality is totally useless because x squared is of course bigger than -3. So let's just focus on x squared is smaller than 3. You can solve the inequality by treating this as an equation. We get the critical values or the roots plus minus √3, and then we solve the inequality by the sign diagram. We draw the number line and we'll get plus minus plus. We can only use the interval in the middle. So in conclusion, the expansion is only valid for x is between negative √3 and positive √3. Alright, now this is a problem solving question in your textbook. Find the first 4 terms in the expansion of 1 plus 2x all to the power of -1. So this is the expansion if you just use the MF19 formula. And part B, show that 1 plus 2x to the power of -1 is equal to this in the end. So this is equal to, if we just multiply by x over x, this is equal to x plus 2 all over x to the power of -1, which means we can flip this x over x plus 1 without the power again, which means we can maybe just divide both parts by 2 x over 2 plus 1, or we can rewrite this as x over 2 times 1 plus x over 2 to the power of minus 1. So as you can see, this part in blue here, this expression is exactly the same as this expression. Now, if we use the binomial expansion for the green binomial here, we get this. And if you multiply by x over 2, we get this. So that means the expansion, if we are using the blue form, the expansion is this guy right here. But the expansion, if we use the green form here, we get this. And if you compare these two, you see that they are very different, right? So, to answer part D here, explain why your expansions are different. Let's just look at the restrictions. For the blue expansion, because in the parentheses here we have 2 over x, so the modulus of 2 over x is smaller than 1. Yeah, this is like a fraction is smaller than 1. Like, for example, 7 over 10 is smaller than 1. So if we flip the fraction, of course it's going to be bigger than 1. And then we solve the inequality, we get x is smaller than minus 2 or x is bigger than 2. But for the green expansion, here inside the binomial we have x over 2, so the restriction is that this x over 2 must be smaller than 1. So if we just solve the modulus inequality, we get x is between minus 2 and 2. So the answer is why your expansions are different. Well, that's because they are valid for different values of x. So if we plug in something smaller than minus 2 or bigger than 2, we have to use the blue expansion. But if we want to plug in something between minus 2 and 2, we use the green expansion. So as you can see, it is really important to use the valid values of x. That's it. I'll see you again next time.